friends. Had to do the first problem just to make sure it was working. So now here we go with the rest of the first 2 pages. Question number 2, figuring out this limit without any numbers there. All right, so this is the limit as x approaches negative infinity. Notice you have the square root of x squared. So if we concentrate on the largest degree term of the numerator, okay, so I'm going to say look at negative tx, and I'm going to look at the square root of x squared, which is, the absolute value of x. And I'm going to think about that expression's limit as x approaches negative infinity. Okay. So as x approaches negative infinity, that x will be, this x right here, will be numbers that are more and more negative. This x will be the same way, but it will be taking the absolute value. So we'll be getting positive numbers down here. We will be getting negative numbers but for that negative x. So if you put it all together, that limit value is going to be t. Don't let the t throw you off. It's just like having any other number there. Okay. So if you need to put a number in for t and then start plugging in some x numbers to kind of see what's going to happen, you can do that. Question 3, making this function be continuous. All right, so we need to be continuous at 7. We need the f of 7 to equal the limit as x approaches 7 from the, oops, I kind of got an arrow and a 7 at the same time. X approaches 7 from the right of this function. The limit as x approaches 7 from the left of this function. I need those to be equal to each other. So f of 7, well, when x equals 7, the function equals k squared minus 2. These two limits are going to actually be the same, because notice x is not equal to 7 incorporates the left and the right limits. So if I come over here and I think about the limit as x approaches 7 of x squared minus 49 over x minus 7, I realize that I'm getting a 0 over 0. So if I use factoring to help me on this one, I'll have x plus 7, x minus 7, x minus 7. So the limit is 14. So k squared minus 2 equals 14. If you just write down that statement and you don't show how you got it, you're not going to end up getting full credit. You have to show how the limit definition of continuity led you to this. So k squared equals 16. So k equals plus or minus 4. All right, all the statements that are true about this graph. Well, the first statement is that the limit as x approaches 2 is 1. If I'm on the graph driving towards an x of 2, I am driving towards a y of 1, so that is true. The limit as x approaches 1 from the left is 1. Well, here's 1, and here's the left, and here's the right with relationship to 1. Looks like the limit as x approaches 1 from the left, it would be 0. F of 2 is undefined, not true. F of 2 is that point right there. The limit as x approaches 3 is 2. Well, here's here's x equals 3. And on the graph of the function, it looks like, yes, if I approach 3 from either side, I come closer to a y value of 2. And the limit as x approaches 2 equals f of 2. Not true. The limit as x approaches 2 is 1. F of 2 is 2. So where are the discontinuities? We have a discontinuity at x equals 1, which is a jump or non-removable. And we have a discontinuity at x equals 2, which is a point removable. All right. Let's see what else we've got to do. Proofs. So I've got two proofs to write here. A proof for continuity at -2 and a proof for continuity at 1. Okay, so proof for continuity at A, we need to look at f of A. We need to look at the limit as x approaches A of f of x, which typically means we may have to consider left and right limits. And then if we're going to get continuity, we have to be able to show that that's going to happen. Okay, I'm hoping that was just a pause. Let's go ahead now and do our proofs. We'll do a proof for 1 first, and then we'll do our proof for -2. All right, so to start my proof about 1, first thing I'm going to look at is f of 1. And in this case, f of 1 would be 5 minus 3 times 1, which would be 2. All right, go to the one where it was equal to 1. Second one, I'm going to get into my left and right limits to get my overall limit. I'm going to do my left limit first because it just happens to be the same. The left limit is actually the same as f of 1. So that's 2. All right. So I still have a pretty good chance here for continuity. So next, I'm going to do the limit as x approaches 1 from the right of this function. Now, this is the part that's going to be a little tricky because this means I'm taking the limit as x approaches 1 from the right of x minus 1 over root x minus 1. And once you know it, it's another conjugate. So let's see if we can grab that. Move that. Okay, move this over here. Kind of get this in a different, slightly different screen. Okay. That's already big, but we'll make it a lot smaller. Okay. So, here we go. I'm going to multiply by my conjugate, root x plus 1, root x plus 1. So that means I'm going to find the limit as x approaches 1 from the right. I am not going to multiply or multiply out the non-conjugate guys. I'm going to let them sit next to each other. I am going to multiply my conjugates. Root x times root x is x. Outside insides are going to cancel to 0, minus 1. And if it's a real 0 over 0 problem, this is what should happen. After your conjugate multiplication, you should see a factor and a factor here that you can divide out. So that limit is coming out to be 2 as well. So to finish the proof, that means that f of 1 is equal to the limit as x approaches 1 of f of x. So f of x is continuous at x equals 1. Now, I'm going to go through the exact same process, but for the -2. So I'm going to grab this whole function, send it to a new page, so we have room. And so now let's do the -2 proof. Right. F of -2 is 5 minus 3 times -2, or 11. Once again, there's the equal to part. The limit as x approaches -2, and I'm going to do the right side first because the right side happens to be the same as the middle one. This is the right side, seems to be the easier one, and it's equal to 11. Okay. So once again, I'm still in possibility for continuity. The limit as x approaches -2 from the left of, oh my goodness, this whole time, why didn't you tell me? Because you're not live. These have to be G's. Oh, pooperama. Okay, these were G's. The nice, I mean, you know, if you ended up doing this like I'm doing horribly right here, and you did the whole thing with F's, you might get docked. But honestly, most readers, most test graders for the AP exam are pretty understanding. And so if it's supposed to be an F, or supposed to be a G, and you do an F, as long as there's no other G in the problem where you're secretly, where you could be talking about, you just obviously made a mistake and talked about the wrong function name, but you meant that function. As long as you're consistent, they'll typically be okay with you. Because look how easy that is to do. All right, so I'm finishing the G's for -2. So the limit as x approaches -2 from the left for g of x is a limit that doesn't exist. A -2 plugged into this function, no, I'm lying, it's not, I don't know what I'm thinking. I'm losing my mind. That's 6 over -2 minus 4. So it's 6 over -6, which is -1. I guess I was thinking ahead. So what does that mean? Well, it means that the limit as x approaches -2 for g of x does not exist. The left and the right limits are not equal. Therefore, g of x is not continuous at x equals -2. All right. We have worked our way through both proofs. Let's see what else we've got on this page. Find points of discontinuity, find the limits. Okay, so discontinuities, things that create discontinuities. Holes, vertical asymptotes. So let's look at this function and maybe do a little factoring. You have the numerator, factor out that GCF of 3x. Maybe a little trinomial factoring in the denominator, x minus 6, x minus 1. So it looks like we have discontinuities at x equals 1 and x equals 6. X equals 1, there's a hole. X equals 6, there's a vertical asymptote. So if we do the limit as x approaches 1 of f of x, my x minus 1s will cancel out, and I'll be looking at 3x over x minus 6. So that value is negative 3/5. When I look at the limit as x approaches 6 of this function, I'm going to get 3 times 6 over 0. That limit does not exist. Okay, understanding the definition of continuity, we did a problem similar to this in class. This is just really a check on understanding that definition. If we are not continuous at 9, but the limit exists, what kinds of things may or may not be true? Well, for example, for the limit to exist, the left and the right limits have to exist. So A must be true. You can't have the limit at 9 equaling 13 without the left limit at 9 equaling 13. B is never going to be true, because if B were true, then that would make it be continuous. But what the actual value is for V of 9, is there a value or is there not a value? I don't know. So is there a V of 9? Maybe. It could be that there's a function value at 9 that's just completely different from 13, or it might be that there's a function value, there is no function value at 9 at all. Okay, so we might have a connection with a point, or I might just have a connection. Okay. Last 3 questions. A little bit of limit laws. The limit as x approaches 1 of the sum of these 2 functions means we're going to look at the limit as x approaches 1 of one of them, plus the limit as x approaches 1 of another one. So this will be 2/3 plus the natural log of 1, and the natural log of 1 is 0, so that's just equal to 2/3. Same thing with the sum here. The limit as x approaches infinity of 2 plus the limit as x approaches infinity of 2 over 3x. The limit of a constant is always a constant. In this case, 2 over 3x is bottom heavy, and so that overall value is going to be 2. And then the last one, the limit as x approaches 0 from the left of 2 over 3x. So maybe we think about a table here, and we look at approaching 0 from the left, so coming from -1, -0.5, -0.1, and we put 2 over 3x, so that would be -2/3. This would be -2 over 1.5. Okay, so -2 divided by 3/2 be -2 times 2/3. So that would be -4/3. And then this guy, 2 divided by negative 0.3 would be 2 divided by negative 3/10, which is 2 times negative 10/3, which is negative 20/3. So these numbers are getting more negative. Negative 2/3, negative 1 1/3, negative 6 2/3. This is going to, it's not a limit that exists, but it is going to negative infinity. All right, and that's the end of